Hello everyone and welcome back to the course. In this lesson, we ascend to the summit and we descend to the abyss as we embark on a journey for minima and maxima in calculus. In the previous lesson, we worked on finding the critical points of the function f of x equals 2x cubed minus 3x squared minus 12x plus 5. And we found that the critical points for such a function were x equal -1 and x equal 2. And as we knew because of the theory, f prime of x was equal 0 at such points. Now we analyzed what happened right before and after the critical points. For example, for the critical point x equal -1, we analyzed that right before that point, the function was increasing, and right after, it was decreasing. Therefore, by looking at the graph, we noticed that the critical point x equal -1 represented a maxima. As well, the critical point x equals 2 represented a minima. Now we can start identifying a pattern, and we might say that every critical point represents either a minima or a maxima. But we have to be careful because such a statement is not true. For example, if we analyze the function f of x equals x cubed, we notice that the point x equals 0 represents a critical point. Nevertheless, such a point is not a minima or a maxima. We only know that right before such a point, the function was increasing, and right after as well. Let us analyze the function f of x equals x times 5 minus x to the power of 2/3. If we apply the derivatives to such a function, after some simplification, we get the following result. F prime of x is equal to 5 times 3 minus x divided by 3 times the cubic root of 5 minus x. Therefore, f prime of x is equal 0 if and only if x is equal 3, and f prime of x does not exist if and only if x is equal 5. Thus, we can say that the critical points of the function f of x are x equal 3 and x equal 5. It's time to analyze the monotony of the function f of x by taking into account the following table made of the intervals -∞, 3 to 5, and 5 to infinity. We're going to take a value between those intervals for determining the type of monotony of the function. For the first interval, we're going to take the value of x equals 0. And if we plug it into f prime, we get a positive value. Therefore, f is increasing in such an interval. As well, if we take the value 4, for instance, in the interval 3, 5, and we plug it into f prime of x, we get a negative value. Therefore, the function f of x has to be decreasing in such an interval. Finally, if we take the value x equals 6, for instance, and we plug it into f prime, we notice that the sign of the result is positive. Therefore, the function has to be increasing in such an interval. So, as there is a change in monotony for the function f of x right before the critical point x equals 3 and right after, we can say that the point 3, f of 3, represents a maxima for f of x. As well, we notice that before the critical point x equals 5 and right after there's a change in monotony, we can establish that the point 5, f of 5, represents a minima for the function f of x. I can definitely notice that you're reaching the peak of your mathematical knowledge, and just because of that, it's time to put it into practice by finding the minima or maxima of those functions. That's it for today, guys. So see you in the next video.